about taking an inverse. How do I go about taking the inverse if I'm given an equation? What do we have to do for that? What do you say, please? Switch the x and the y and then go through and solve for y. Now, how can you tell whether the inverse of a function will also be a function? How can you tell whether or not the inverse of a function, without finding it, will also be a function? Not onto. 1-to-1. Okay? If the original function is 1-to-1, then we know that the inverse will also be a function. Let's briefly discuss this question here. This was your calendar question. We needed to graph this and determine the domain on which the inverse is a function. Let's do this now. Go into your calculators, please, and sign in. So if you didn't grab one, do grab one. You'll need one every day, but on the days where we have calculator-free assessments, just make sure, please, to leave them below. Sign in to your calculators. Go in right now after you've signed in and graph this out. So go in and graph this out. Graph out the calendar function that we had from before, which is 2x squared plus 8x minus 7. And we'll show you a little bit of calculator functionality. Maybe you know it and maybe you don't. We need to figure out where this is, or over what domain this is going to be a function.
Wait, which page is this? Because I can't.
It's the one from last night's homework. The calendar question. This one here. Now, when you go through and graph this out, some of you are noticing an issue that you have already, and this person already rectified it. Can you see the vertex, the bottom, the minimum of this graph? No. So they went through, whose is this? All right, so when you did this one out, Jensen, did you manually do it? Okay. Take an attempt, manually do it, see if it works. We need to do something so you can see that lowest value. Now, once you're able to see that, we need to restrict this domain such that the inverse is a function. Why is the inverse of this f of x not going to be a function as it currently stands? Hands up, please, if you can tell me why the inverse of this function will not be, or sorry, why the inverse of this function will not be a function as it currently stands. Tyler, what do you say? It's not 1-to-1. And the problem is that when we reflect it over the diagonal, y is equal to x, we're going to get a parabola that opens to the right instead of up. That would fail the vertical line test, which means the inputs have more than one output. Now, from this point here, if this is the graph that we're going through and looking at, how can I figure out what domain to restrict this to such that it is 1-to-1? Well, I need to find this lowest point here. Now, some of you may have tinkered around with the calculator and used some form of table. I can assure you tables are wonderful, but they are not the be-all, end-all. What you all need to do is, and let me ask this, have you found, raise your hand if your teacher showed you previously how to find a maximum or minimum in this calculator? Fabulous. So let's go into menu. And some of you do the scroll, just so you can hit the number in front. We need to analyze the graph, so you press 6, and then I would go down. Now, am I finding a max or a min to find the turning point on this graph? Min, so that is a 2. And you would go through somewhere, so your pointer is somewhere to the left of it, but nearby, and then you hit enter, somewhere to the right of it, nearby, and hit enter. And what is the lowest point that this reaches? Well, it happens at -2. So there's two different answers that you could pick. Two different domains that we could restrict the original to so that the inverse will be a function. Who can tell me one domain, restricted domain option for this so that the inverse of it will be a function if we know the lowest point here is at -2? What do you want to say? We could say negative infinity to -2 will restrict our domain to be from negative infinity to -2 with a bracket there. Or there's a second viable option. What do you want to say? It could be -2 to positive infinity. You just can't use the whole thing. You can use the individual halves. It doesn't matter which one you use. It's just going to alter what your inverse is going to look like. Questions on that? All right, then let's bounce forward, please. Today we're going to talk about a piecewise function. Hands up, please, if you've heard of piecewise functions before. Good. We are, by and large, you come in with stuff that because again, this is my first Common Core rodeo. So you come in knowing stuff that I didn't think that you know and not knowing stuff that I did. A piecewise function is just the graph of different functions, different pieces of functions over different intervals. They don't necessarily need to connect. There can be colossal gaps in them. Coming up with the definition of them can be very difficult, but we'll get through. So piecewise functions are pieces of all different functions all on one graph, and a piecewise y is defined differently at different intervals of that. You may be graphing on the same graph, an absolute value, a line, a parabola, and so on. The easiest way to think of them is to draw each function on a graph and then erase the parts that weren't supposed to be there as determined by the x values or by what the function is telling you. I'll tell you this, I'm very old school. We are going to stay away from using the calculator to give them out because the calculator does a bad job of one really, really important thing, especially when you get to calculus. We're going to be doing a lot of them by hand. What that means is you're going to be literally doing a plug and chug many times through this graph to get a general trend. We're going to view it in pieces. We'll do it as though the calculator isn't there at all. Okay? And then when the calculator is there, it just makes it easy to confirm what we have. Yeah?
I can't actually put piecewise functions in the calculator with ease.
Good. We're going to show you how to do it at the end. The instructions are in there for later. If we're doing this out, when I see this piecewise function, if this is what I have, if this is my example, to the left of -2, I'm graphing a line. To the right of -2, I'm graphing a parabola. Now, when I give this out, if it was me doing this graph and it wasn't given, I'm going to ask you this. Where does the transition occur? And when I say that, I'm asking, where does this move from one piece to the other? And in this case, it would be at -2. So when we do it out, I'm going to ask you to sort of put a barrier somewhere along where that transition is going to occur. And then I'm going to pick some values to the left of it to build the left-hand piece. I'm going to pick some values to the right of it to evaluate out the right-hand piece, and so on. But you could literally get it, well, let's say this. If I were going to sketch this out and use a table, I'd say, all right, here's my x and here's my y. Now, I'm going to have a transition at -2, which means I'm going to list out a -2 twice. That's another thing that some of you might not be accustomed to. The transition value gets listed out twice. So I'm going to go to the left of it, which would be -2, -3, -4. Over here, I'm going to do -1, 0, and 1. Now, looking at this, when I plug in a -4, hands up, please, if you can tell me which piece if I'd be using. Am I going to be using the yellow linear piece or the green quadratic piece if I start off by plugging in a -4? I've got 1, 2 so far. Jonathan T., what do you say? Which one am I using?
The yellow linear.
Good. So when I plug that in, 2 times -4. Hands up, please. We tell me what 2 times -4 is going to be what? -8 plus 8 is going to give me out a 0. So I'd list this out. Next one up, -3. -3 uses that yellow piece. And when I plug that in, 2 times -3 is -6. Add 8 to it, and that gives me a +2. At -2. Now, You're going to be using both. Understand that. We're evaluating the transition twice, and you're going to see how we denote it. At -2, where the switch between the graphs is going to occur, if I'm so far operating in the yellow, I'm going to stay with the -2 into the yellow. -2 times 2 is going to give me 4. -4 plus 8 would give me a +4. Now I'm transitioning down to the green piece, the quadratic. When I plug a -2 into the quadratic, I get -2 squared. Don't go to the calculator. That should give you out a 4. And then when I plug in a -1, I get a 1, a 0 is a 0, and a 1 is a 1, and so on. Now, actually, I think we can fit, yeah, you can fit 3, 9, or sorry, 2, 4, and 3, 9. You're expected to fill up the graph, not give me little stumps. Now, the problem that we have is this. One of these includes the 2 and is going to have a closed circle. One of them is going to have an open circle. So when I'm looking at this, I'm going to be remember, because this was our transition value. This is the actual point at -2. At -2. I'm going to use the yellow graph here, the top linear one. -2, 4, that's going to get the closed circle. It goes up to -2, but doesn't include it. So like -2 point, it's greater than. So we have something like -1.999. That would be included in the graph. So we're going to give an open circle at that one. So if it doesn't include it, we give it an open circle. If it does include it, we give it a closed. The reason being, while -2 isn't included in the green quadratic graph, everything immediately to the right of it is. So you do need that in the list to point out with an open circle. Now we're lucky on this example because this function here, while this is open, this point comes along and closes it off. That's not the case every time. Questions on that? Now, what is the domain of this graph going to be in interval notation? Chloe, what do you say? Terrific. Absolutely terrific. Negative infinity to positive infinity. Hands up, please, if you can tell me what your range on this graph would be. Johannes, what do you say? Terrific. It's unbounded above and unbounded below. Questions on that? Next one up, we're going to graph this, state its domain and range. Now, here's our first piece. Now, there's a transition that occurs. Where is my transition going to occur? Sarah L., what do you say? So I'm going to go through, and on my axis, I'm going to give a little, very faint dash, because it's not part of the graph, and when you're done with it, you're going to get rid of it. Very faint dash there. Now I'm going to go through when x is less than negative, and we have two pieces. I'll highlight them so we know the difference, and we can talk about them clearly. The yellow piece is for every x that is going to be less than 1, or to the right of my boundary. And I'm going to say something incorrect here. You all will figure it out in a minute. To the right of my boundary, I'm going to be graphing the negative x. What did I say that's incorrect? I said to the right of my boundary, which was at 1, I'm going to be graphing out a negative x. What was incorrect about what I just said? It's from the right up to what value? 5. So I'm going to have to take into account my transitioning values. So I go through and say, all right, this is my x and my y. I'm going to give out some values here. The switch occurs at 1, so I'm obviously going to need to use 1 twice. Let's say I'll do -1, 0, then I've got 1, 1, so that ends the yellow graph and starts the green, then I do 2, 3, and so on. We can continue that pattern because both are linear. When I plug in a -1, which piece will I be evaluating it out in? Maddie? Good, so what do you get when you plug in a -1? Good, so I've got a point -1, 1, so I go to -1, 1, and put a dot. Next one up, Eli, what would you go through and give as your, which piece would you use for 0? Yep, so what do you get when you plug it in? What's your output going to be? 2. Now I'm at 1. What is the output going to be, Noah, at 1? Okay? Now, since this is the transition, I'm going to ask you this. Is this point closed or open? Why would it be closed here?
Because in the equation, for that one has greater than less than or equal to.
Yeah, when it gets the equals, it's closed. So now I'm going to put a closed point here. Now, you put every dot that's going to fit. You are literally graphing a line with a slope of -1. And you're going to sketch that, and it would look something like that. Now, for the next piece, I'm going to transition over, and now I'm graphing y equals -x from 1 and beyond. So, Alyssa, what would you go through and get when you plug in -1 into the green piece? Or sorry, is it a -1? Sorry, a 1. Good. So I've got the point 1, -1. What about when you plug in a 2? And when you plug in a 3? Terrific. We've got 3 points. So I'm going to go 1, -1. So I go 1, -1, and put an open circle. Then 2, -2 goes here. Now, I'm going to keep this going like this. Is that right? Hands up, please, and tell me what I need to do to make this correct. We're going to stop at 5. Do I put an open circle at 5? Yes, you do. So at 5, because it goes up to but does not include that value. Looking at what's there, Emma asks, what would the domain on this be in interval notation? Negative infinity to what? I'm sorry.
5.
Terrific. It goes up to but does not include 5. What about our range on this? Michael, what do you say? No? Be careful. 5? Negative infinity all the way up to 3. Do I have a bracket or parentheses, Tyler? Questions on that? Next one up, we're going to graph this out, state its domain and range. That's the piece that's missing. Now, there's actually 2 transition values in this graph. Peter, what's one of the 2 transition values in this graph? -5. And then what's the other one going to be, Jason?
Wait, sorry, can you repeat that?
What's the second transition value? Where does the second transition value occur? We stated one
goes
was,
from -5 to 3.
so the second transition would occur at what x value?
-5.
We have that one. What's the other one then?
Oh yeah, from 3 to infinity.
Now, keep in mind, when you give out your final graphs, you're going to be ignoring those lines, and they shouldn't be on your paper. This first one is going to be hopefully kind of easy. If I'm building out a table of x, y values, this piece here, this first one, I'm going to use for everything where the x's are less than -5. So let's say we'll use -7, -6, and -5. What is the output at -7? Peyton, what do you say? Which piece would you be using if your input is -7? The first, second, or third? No? Because that tells you that the x, you use this when the x's are bigger than 3. If your input is -7, which criteria does it meet? The first one. So what would your output then be? What about when you plug in a -6? Courtney, what do you say? And when I plug in a -5, now, since this is where one of my transitions occurs, this I'm going to leave with a 4. Is this point here, -5, 4, right here, is that going to be an open circle or a closed circle? Okay, what do you say? Because it goes up to but doesn't include it. Now, to list out those points, and it's going to continue, the trend continues going to the left. It's going to be a 4 open circle here, and then these I'm going to give out as dots would look like this. It's called a constant function. It's a type of linear function. By the way, would that be an x equals line or a y equals line? Emily B, what do you say? It's going to be a y equals. Now, let's transition over and use the middle piece now, which says take the absolute value of your input and then add 2. So, Jensen, I'm going to plug in a -5. What do you get when you plug in a -5? Let's do now -4, -3, -2, -1, 0, and we're going to keep going. Now, when I'm at -4, what's the output going to be? Colleen B?
6.
When I'm at -3, Taylor? When I'm at -2, Jess?
Sorry, I'm like a little behind.
Which piece would you be using if your input is -2? The first, second, or third one? So, because that's the one that meets that condition, because the x is somewhere between -5 and 3. So plug a -2 into that piece. What's the absolute value of -2? How far away is 2 from 0 on the number line? 2. And then you add 2 to it, and what do you get? Next one up for -1. Alexa, what do you get when you plug in a -1?
3.
Next one up, I'm going to plug in a 0. And Vicki, what do you get for that?
2.
Now I'm going to plug in a 1. And Trevor P, what do you get then?
A 3.
I plug in a 2. Allison L, what do you get then? Now I'm at 3. Jack, when I plug in a 3 into the original function, into this middle wedge, what would you get out? 5. Is that going to have an open circle or a closed circle? Now I'm going to transition over to the third piece, and I'm going to do a 3, and we'll list out a 4 and a 5. Looking at that, when I plug a 3 in to the third piece, Tyler, what do you get as an output? When I plug in a 4, Jonathan, what do you get as an output? And when I plug in a 5, Chloe, what do you get? So now, looking at this, when I plug a 3 into the bottom or last piece, Johannes, is that going to have an open circle or a closed one? Before I give this graph out, does anybody notice something that I'm going to have happen in this graph? you're going to have two open circles at 3. So when we're graphing out in the beginning, you all will struggle with this, and that's fine. Remember this here and this point here, though, would be close. So I'm going to go to negative 5, 7, which is here. And then I'm going to go slope down 1. So I get to here, and then I start going back up. And I have two open circles, so this here and here. That's what that would look like. And 3, 7, 9. So this would be 4 is 7, and 5 is 9. I actually can't fit any more on it. So that's what your graph is going to look like. Based off of what's there, we now have to answer the domain and the range questions. Go through and give both of those domain and range questions a try on your own right now.
It goes right up to the 3. You know what I'm saying? Because it's greater than 3. Like, while 3 isn't there, 3.00000001 is. So we're going to say open circle there. Just plug it in 3. You use it with both.
Yeah.
Like where those transitions occur.
Mhm.
You go through and do it at both, wherever it is.
Yeah.
You plug, so if there's a transition variable like 7, you plug it into both.
Now, looking at what's there, Colleen B, what would your domain on this graph be? No? Careful. You have to use the x values that these happen at. So negative infinity up to what? Where does your jump occur at? What x value? It'll be at, where's the only x value that's not used? You said negative infinity, all of them are used up until what x value? 3. So I'd say negative infinity 2. Good. Now, does the graph stop at 3? You just have to jump over it and then resume. So, how do I jump over it? We put a U there for the union of sets. What's the second interval then going to be?
3.
See how it continues out forever? So list that as 3 out to positive infinity. How about our range? What would the range on this graph be? Vic, what do you think?
Graph it to positive infinity.
The lowest output value that we get is 2. Everything above the 2 is used. You do need to be careful. There is a little bit of a danger zone. You have an open circle here at 5. So 5 isn't in the output or in the range here. Where is it used in the range? Yeah, over in this area over here. So as long as it's used somewhere, but beware, if you were to graph this out and that value was omitted, you have to omit it in the range as well. Something has to use it. Just because you have an open circle there doesn't mean that it counts. Now, we're going to go through and graph a piecewise function out, and you guys get to watch me stumble over this because I have not done a piecewise function in the calculator before because they are terrible at doing piecewise functions. Go in, please. What's our first step say? So go in, we're going to add a graph. So go into 2. And the first thing that we're going to do, and actually, by the way, here's one thing. Some of you notice, see how this dumps you down into F2 because you're already in F1? The way to avoid that happening, and this is my advice for you, and we'll say this nicely, some of the teachers are very good at getting you into the door on these calculators, but not going all the way through with them. when you're doing questions, every question essentially you should want to restart from the beginning. You don't want to have like 45,000, or at least it gets muddied up if there's 45,000 tabs open. We've had problems before. You'll have some where we're talking about, f of 10 or something like that, where you're graphing 10 things on a set of axes. We don't want that if you don't delete it. So what we need you to do is, and I think I have this right, go into doc, press doc. Yeah, go down to go down to 4. I think that it's 4. Insert new problem, which is 1. Now, see how it starts over with 2.1? So that would reference problem 2, because the other graph that we did would be problem 1. The reason being, and you won't see it, I guess, now, when we're doing these questions out over and over and over again, there's a lot there, and instead of constantly going back out, forming a new document, deleting all the stuff, and not saving it, you could literally just do that sequence, go into doc, and get a new problem. But when we graph this out, so what's it tell us to do on the first step? Let's stumble through this together. We're going to graph that particular f of x. Then you're going to go into, so as long as you're here, you're going to go into this template button, which is right there. So press that. The piecewise function, we're going to say it looks like is this one here, so we can enter multiple pieces, not just 2. So how many pieces does our piecewise function have? 4. So go in and hit 4 and press enter. Now, the first thing that you're going to do is enter the expression, which in this case is 4 minus x. And now arrow over to the right. What is the criteria to use there? Well, it's going to be x is. Now, if you ever need a symbol to show up, and we're going to show you this, this is going to become one of your most used buttons. Hit Control equals, and all of these show up. So in this case, what was it, less than? Less than -2. And remember, you use negative, not minus. Now, you're going to fill in the rest of those. Okay, press enter when you're done. It's going to give out a piecewise graph. What's the problem with these piecewise graphs? Well, I look at what's there. And actually, by the way, if you could, grab this and slide it over. Move your finger around on that center nub there. It's going to be a graph. So I think if you hit enter on it and then just move the cursor around, it'll shift where that is. Now, did we have this right? Negative. Yeah. All right. So there's a big problem in this graph, and this is why I get so apprehensive for you to be a slave to these calculators. Does anybody see what the problem with this graph is going to be? With that? Not only that, yeah, there's something, though, with this specific problem that's not showing up that needs to be there. Take a look at what's there, what needs to be there.
The inequality is, I guess, the open holes or the open dots that close down.
Yeah, I'm seeing something, though, I'm looking at that and I'm going, something needs to be there that's not there. Look at what's happening. At 2, your output's a -3. Do you see that on this graph? No. This is supposed to be an open circle here, is it? Is this an open circle? Yes or no? No. Not at all. And that's why I always take issue when you become a slave to these calculators and you don't think, and you have these people who show you, oh, you can just type in and get it. There's a problem with that. The technology is not as smart as people. It's never going to be. You have to be able to analyze that graph and make that connection. You should be able to look at this graph right now and say, there's a disconnect happening. We know that this is going to go to 6, because 2 squared plus 2 is going to give you 6. This is 6 everywhere after. It's a constant function. The problem is, right here, you're supposed to have an open circle. You don't. Down here, you're supposed to have a point. You don't. Is that an issue? Absolutely. So, what's it say? It says it like right underneath one of them. What important details, if you take a look at the bottom right, what important details aren't included that need to be included? The open circles and the closed points. Now, I think hopefully we can bounce over and finish this rather quickly. So we do all this, we answer these questions out. Here's one, too, that comes up quite frequently. The absolute value function. Now, go into your calculators, please, and graph out the absolute value function, because we're going to be writing this out as a piecewise function. Go in right now, graph it out, and let's take a good look at it together. By the way, do you know where you can find the absolute value bars? Under that template button. So go in, find your absolute value bars. They're right there. It's very awkward to see because these screens are so tiny. Then you've got x minus 4. So when I go through and I sketch this out, what I need you to do, so press enter. We're going to be looking at the same window. What I need you all to do is this. On your paper, I want you to go through and give a sketch of this graph. So go through right now, please, and give out a sketch of this graph. And we're going to give this out as a piecewise function, because looking at this right now, there are 2 pieces on this graph. There's 2 pieces that make this up. There's this piece in yellow and this piece in green. Now, I'd say if I were to rewrite this as a piecewise function, I would say that the f of x is equal to, I have 2 pieces. And maybe figuring out where the separation is going to occur will be the easiest part. Looking at this, where am I transitioning from one piece to the other? At what x value? Jason?
Wait, oh yeah, positive 4.
Positive 4. So I'm going to say one of the pieces I'm going to use when x is greater than 4. One of the pieces I'm going to use when x is, and actually we'll do it less than greater than. One of them needs to be included. Now, it doesn't matter which one you pick for it to be included. So, Sarah L., do you want it to be included on the first piece or the second piece? Now, our first piece is the one that we're using when x is going to be less than 4, less than or equal to 4. Looking at what's there, that's a line. You can give the equation of that out kind of really easily. Hands up, please, when you can give me what the equation of that green line is going to be. You love it. Again, if you made it through Geo Enriched, you can do this. We've got 3 people. This is personally, my heart is breaking in a million pieces of front of you as we speak. We may need to call the janitor to pick them up. What's the equation of that green line that's there?
Oh no.
Hang on, there's 26 of you. Go outside. Look for the thin and beautiful guy in the black shirt that's calling out your names. The only thing that makes this better than missing 5 minutes of class is coming in and it smells like pumpkin
spice. It really does.
cookies. And you all, just so you know, rated the smell the lowest out of every class
It smells like
yesterday.
Cliff Bar. It smells like Cliff Bar.
Okay, good or bad? Okay. They came in, they go, it was wonderful. Oh, it's so terrific. And all it does, you know what I'm most acceptable is that? It masks.
Do you like Cliff Bars on the wall or something? Because I
No, it's right over here. We'll come up with new ones, maybe Christmas. We'll have like a all right. In any case, what we need you all to do is this. Let's finish this out quickly. This would be a line, and the green, the slope is -1, so it would be -x. With a +4 as an intercept. This in the yellow would be an x -4. The shortcut is you look for the transition value, you go the positive and the negation of the argument or the inside of the absolute value. Now, what we, does this put us at the end of the packet? Woo! So lucky. You're lucky we didn't, well, I guess luck is whatever you want to make of it. You all have to finish. I get questions from the sheets, from the calendar. Is there, looks like we're going to try to fit in. I'll say this, for this unit only, you will have a review day. And please don't expect them in other units. For this unit only, and we may be going back to finish up questions that we didn't answer previously. But next time we have classes review, make sure you get worksheet number 5 done. Put your calculators back in the right spot. Run to your other unimportant classes.
So physics is not important.
Physics is a cousin of math, so it's moderately important, just not as important. Physics is cousin of math. Why would you take physics? You gotta learn the jobs that rule the world. Why don't you want to be here?
It's hard. I don't know what I got on my geometry exam.
What?
69. I was wrong.
Do you think that you're conducted to that for the rest of your life?
Yes.
I'm going to tell you this. How about you switch those digits and we give you, what would you see there? 68? 69, so you're going to get a 96 this year. If you work towards it. If you work towards it.
Wait, Matt, so do we have to do, what questions do we do? Like, because I finished the homework packet.
Okay. It's whatever the packet said to do.
Oh,
This one is not you. These two are you.
what's me?
And this and this. There you go. Grab a calculator as well.
Oh, wait,
We might do some of those examples that we didn't get done next time. You're free to do as much as you'd like.
Oh,
and you can go over them if you have. You're very welcome. Okay? Hey, Jason. Yes.
I could turn in my day 2 homework last time, but I went to a lesson, so do you want me to turn in with my day 3 homework?
Just do me a favor, just leave it on my desk.
Okay.
Okay?
I did in class
All right, well, take this out, please. Make sure your note packet is out from the other day. Have your note packet out, please, from the other day.
Which one?
Oh, are you gonna get, people coming up saying you were talking about?
That one. Everybody has one. I didn't think this you needed. I know. I just wanted to know we were up. No, it was. An alternative. Start that relationship with not a bad.
No.
By the way, this is a little bit.
Sign into your calculators now. Sit down and let's see how long it takes us to be quiet.
Not much anymore. They used to do one of our standard being solid linear algebra circle linear.
Well, if you ever okay, let's go over the basic terms. Like literally, yes.
Okay, and these are all things that they should have done last year, right?
I take away not,
Well,
I was going.
P.
Yeah, the identity function, yeah. So like there's some, I focus on.
Well, I can ask, because this would be good to make sure that I'm.
Hang on one second. So we got a new one.
All right, so you all should have. Now, there's two sheets that you all picked up when you came in. Please understand this. We're getting up and wrapping up, getting towards the end of this unit. Most units we will not be having, and this might be different than things have operated for you in the past.